Okay, derivatives of exponential and logarithmic functions. We've already seen that the derivative with respect to the x of e to the x is e to the x. So this is an exponential with a base of e. The question is, what happens if we change the base so that it's not e? What if it happens to be 10 or 12? And there is a formula for that, and it looks like this. So the derivative of a base, as long as the base is bigger than 0, to the exponent of x is equal to ln of that base, and ln is log base e times b to the power of x. That's why when you take the derivative of e to the x, this formula works. It's ln e times e to the x, substituting in a b, an e wherever there's a b, and this part's equal to 1. Here's how it works with some other examples. So the derivative of 8 to the power of x is ln 8 times 8 to the power of x. And the derivative of 5 to the power of 4x is ln 5 times 5 to the power of 4x. But notice this 4x isn't just an x, so I need to apply the chain rule and also multiply it by 4. For logarithmic functions, if we want to take the derivative of a log, here's the formula. And you'll notice that if we use this formula for ln, we get 1 over, well, this is base e now, so this is ln e times x, which is just 1 over x. And the condition on this is that the x value has to be bigger than 0. Here are a couple of examples. Example 1, if I want to take the derivative with respect to x of 3 ln 2x, I get 3 times the derivative of ln 2x, which is 1 over 2x, times, because this isn't an x, chain rule applies, multiply it by 2, and I get 3 over x as my final answer. Another example for you. Taking the derivative of ln of this polynomial function, I get 1 over the polynomial. This isn't an x, so I apply the chain rule, and I have to multiply it by 4x cubed minus 2. And I get a final answer that looks a little neater. Note, we don't have to learn about hyperbolic functions in this calculus course. Although it's in the book, it is not on the exam, which is good.